All right, number 2, we want to evaluate the square root of negative 144. Okay, so you want to be familiar with your multiplication tables, multiplication facts, however we say them nowadays, because it will help you to break down these square roots a lot quicker. If you don't know your multiplication facts, you can still do it by just reducing each term, which I'll show you that here on this process. Negative under square root gives us an imaginary, and then the square root of 144 is 12, so I would write my solution as 12i. Now let's say, for example, you don't know the square root of 144. You still can pull out that imaginary term because of the negative, and then I'm going to break this square root down. Some numbers will not have a perfect square, but you will still be able to reduce the radical. That's the process we're going to go through, reducing the radical. And by reducing the radical, we will still end up with 12i. So by reducing, I'm trying to figure out what is this number 144 divisible by. Well, since it ends in an even number, I know it's divisible by 2. So I'm going to divide this number by 2. Divide by 2. And that will give us 72. Okay, so I'm no longer dealing with 144. I'm dealing with 2 times 72. 2 is prime, so I'm going to leave it alone. 72 is not prime, but it ends in an even number. So again, I can divide this by 2. 2 times, this will be 36. Okay, so the 72 was broken down. So now I'm looking at 2 times 2 times 36. All right, remember, square root is looking for what number you multiply times itself, or 2 of the same. So since I have a pair of 2's, the same number twice, these two guys will merge, become 1, and they get to come outside of the radical. So this I is still out here. Okay, and now it's being multiplied by 2. You can only pull it out when you have a pair. They match up and they become 1. Now, 36, I can divide it by 2, but I also notice that 36 is a perfect square, so I'm going to write 6 times 6 just to save me some time. So if you were to multiply 2 times 2 times 6 times 6, it would give you 144. And notice again, I have a pair of 6's, so I will circle these. These two will become 1. And if you pull out multiple numbers from under the radical, all you're going to do is multiply them together. So if I multiply 2 times 6, sure enough, we get 12, and it's 12i. Okay, so that's how you reduce a radical, because sometimes we will not have perfect squares, but we will have to reduce. So 12i. And then we're going to solve this one. So be careful here, number 3. You have a negative on the outside, and then you have square root of negative 50. Okay, so do not confuse the negative outside the radical as being imaginary the way we do the negative on the inside of the radical. This is not the same. Okay, so you will pull out an I because of the negative inside. The negative outside is just going to make our final answer negative. Okay, so I'm going to pull out the I first. And so that's going to give me a negative I on the outside times the square root of 50. All right, so here 50 is not a perfect square, but I'm going to use the method we just used on problem 2 to reduce this radical. So I'm going to divide by 2 because it's even. So I'm going to say 2 times 25. Okay, and then 2 is prime, so I will leave it. 25 is not. I can divide this by 5. Okay, so that will break down to 5 times 5. All right, I have a pair of 5's, so that means I get to pull one 5 out. They merge, become 1. I get to pull a 5 out. So on the outside, with my negative I also add a 5. Now, the 2 is left alone. It doesn't have any pairs or matches. So it will stay underneath the radical. So right now we have a negative I times 5, and then we have this square root of 2. The 2 did not get to come out of the square root. Now, again, I normally write the I at the back. So I'm going to take this and put the I at the back. So the final answer will look like this. Negative 5 times the square root of 2I. Okay, so this is the way I'm going to write our final answer. Negative 5 times the square root of 2I. Since this is all being multiplied, it doesn't matter. You can write the negative I out front. Again, I'm just used to putting it at the back. That's the way I've done it for so long. So negative 5 square root of 2, arrow out, and then I. Okay, it says that's incorrect. We'll first want to rewrite it and then remember blah, blah, blah. So let me see if they want multiple steps. They want to write it in A plus BI form. Okay, so I'm looking at 150 and not 50. So that's my mistake. I jotted down 50 and not 150. Okay. So let's try this again with the right number. So I'm going to do the same thing. I'm going to go a little bit faster this time. So negative square root negative 150. So I'm going to have a negative I 150. I can divide this by 2 and 75. 75, I can do 3 and 25, and 25, 5 times 5. So again, we still pull out a 5, okay, but this time we have two numbers left, 2 and 3. Both of them will stay under the radical, and we will multiply them back together. So my final answer, negative I 5, because I pulled this 5 out, and then the 2 and 3 will stay. 2 times 3 is 6. So when I rewrite it, I will have a negative 5 square root of 6I. So that will be the difference. Instead of just a 2 under the radical, you'll have 6. So negative 5 square root of 6, arrow out I.